So welcome everyone. This is 11.1, solving quadratic equations by taking the square root. So we've talked about this in a previous lesson. So for example, if we have x squared minus 81 equals 0, how do I go about and solve this? Yes, Alex. Get x by itself, so I have to add 81 to both sides, right? And we have x squared equals 81, and then I'm gonna square root it. Now remember, when I do square root, both sides, x is gonna equal plus or minus, what's the square root of 81? 9, okay? It's plus or minus 9 whenever we square root, because 9 squared is 81, and negative 9 squared equals 81 as well, okay? So that's why we always have to put the plus and the minus, because the positive and the negative number works. Okay? Let's do another example. X squared plus 81 equals 0. Same numbers, just the plus turned into a minus, or the minus turned into a plus, right? So it's the same steps, right? We're going to isolate x by subtracting 81 on both sides. And we're going to get x squared equals negative 81. And then do the same thing, square root both sides. So x equals plus or minus square root of negative 81. Huh. Why am I stopping? Yes. Yeah. Because in this case, right, in our previous lesson, whenever you square root a negative number, we said that there are no real solutions. Okay? This would be our answer, right? No real solution. Okay? Yes. Hold on. Okay? But in this lesson, in module 11, we are going to have a solution, because this guy is going to be involving imaginary numbers. Okay? So what are imaginary numbers? We're just going to talk about one imaginary number, and that is the imaginary number I. Okay, it's just a cursive I, and that is going to equal square root of negative 1. Okay, now whenever we're come across a square root of a negative number, now we can just plug in square root of negative 1. Okay, and I'll show you how we're going to do that in a little bit. I kind of want to talk about what an imaginary number is and how it works. Okay, so if I equals square root of negative 1, and it's imaginary because there is no real number that gets me a square root of negative 1, right? There's no number out there that you know, right? If you multiply by itself, will equal negative 1. Correct? Does that make sense? Yeah? So that's why we call it an imaginary number. So this imaginary number, I, has a pattern to it. And I'll show you guys the pattern right now. I squared, right? That equals square root of -1 squared, correct? Yeah. I squared, I is square root of -1, so -1 square root of -1 squared. Now remember, the squared and the square root are inverse operations, like addition, subtraction, multiplication, division. Squared and square roots are inverse operations as well, right? So they cancel each other out, okay? So if they cancel each other out, we're just left with -1. So I squared equals -1, okay? I to the third, if you guys remember back to exponential rules, right? I can rewrite I to the third as I squared times I, right? I to the first power times I squared. We add the powers up and we get I cubed, or I to the third power, okay? 2 plus 1 is 3. So since I know that I squared is -1, we already established I squared is -1. -1 times I, that's going to equal -I. Okay? I to the fourth, that is I squared times I squared, right? 2 plus 2 is 4, so I can break it down like this. Okay? What's I squared again? -1. So -1 times -1 equals 1. Okay? And let's try I to the fifth. Okay? That's what? I to the fifth is going to be I to the fourth times I, right? 4 plus 1 is 5. So I to the fourth, we established that it's 1. 1 times I equals I, or square root of -1. I to the sixth, that's going to be I to the fourth times I squared. I to the fourth is 1 times I squared is -1. So the 1 times -1 is -1. So you guys see how we're going back to these two values here. I to the seventh is going to equal I to the third, -I. I can show you that. Yeah, but you guys can kind of figure it out. 4, yeah, 4 plus 3 equals 7. Let's do it. I to the seventh, that's going to equal I to the fourth times I to the third. I to the fourth is 1. I to the third is -I. So 1 times -I equals -I. Okay? And then let's just finish this out. I to the eighth equals I to the fourth times I to the fourth, because 4 plus 4 is 8. That's 1 times 1, which is 1. Right? Do you guys see the pattern? This is your pattern. I to the first is square root of -1, or I to the first is just I squared is -1, I to the third is I to the fourth is 1, I to the fifth is I to the sixth is -1, I to the seventh is -I to the eighth is positive 1, right? So it just keeps on going back to this. So if I draw in this little box the key to I equals square root of negative 1, I squared equals negative 1, I to the third equals negative I to the fourth equals 1. And this would just keep on going forever, essentially. Okay? So if I ask you, what is I to the, let's say 50, 50th power? What we can do, right, I to the 50 is look at this list, right, and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I to the 17, I to the 18, I to the 19, I to the 20, right? And keep on going until you hit 50. That'll just be it. But, thank you. But there is another way, a simpler way. What is that? Divide 50 by 4, right? You get 1, 4, 1, 0, 2, 8, 2, remainder 2, right? So what 12 remainder 2 means in this case, it went around this cycle 12 times, right? So the 12th time, let's say I went 1, 2, 3, 4, 5, 6, 7, 8, all the way to 12, that's I to the 48. 49, 50. It's negative 1. Okay? That makes sense? Yeah. So this I to the 50 would equal negative 1. Okay? We just use this pattern to figure it out. Okay? Cool? The important part about this pattern and what we're going to use to solve, going back to solving quadratic equations, are just these two. Okay? These two guys are going to be what we're going to use to solve quadratic equations. All right? So let's just run through some examples. Okay? The first example that I have for you is x squared plus 12 equals 0. Oh, class, hold on. Before we go over this example, let's go over this example, right? We didn't finish this one, right? So before it was no real solutions. Yes, that's still correct because there's no real number, but there is an imaginary number. What does square root of negative 81 break down to then? X equals plus or minus square root of negative 81. Yeah. Negative 1 times square root of what? No, negative 1 times square root of 81, right? Because 1 times 81, right? I can break this down, class, into plus or minus square root of negative 1 times 81. correct? Now, since there's two numbers inside one square root, I can split them up and say -1 square root of -1 times square root of 81. What is the square root of -1? I. What is the square root of 81? 9. So x is going to equal plus or minus 9i. That's it. It doesn't have a real solution. It has an imaginary solution. Okay? That's just the way that the imaginary number works. Okay? And like I said at the end, these two are the ones that we're going to be using. Okay? Focusing on, essentially. All right? So if we have this, x squared plus 12 equals 0. Again, we are going to try and isolate x squared by subtracting 12 on both sides. X squared equals -12. And then square rooting both sides. So x is going to equal plus or minus. Whenever I see a negative in my square root, what am I going to do? How do I take it out? No. Square root of -1, right? So, like I said here in our first example, right? We can do this, right? Or we can just bypass everything. Whenever I see a negative, I'm just going to pull it out and put an I there. Okay? Because that's the end product, right? The negative just comes out by this, doing this, and then just comes out as I. I'm just going to pull it out right here. So that's I square root of 12. Right? I saw a negative. I just pulled it out, stuck an I there. Okay? Now with this 12, I have to break it down. 12 is what times what? 6 times 2. Okay. 6 breaks down to be 3 times 2, right? Now that I see two 2's, right? I see a pair of 2's. So they come together and come out of my square root. So it's 2i square root of 3 plus or minus equals x. That's my answer. Yes. Yes. I'll show you guys another way you can think about it. X squared. Let's go with plus 36. Let's say 2x squared plus 36 equals 0. Okay. Let's try that one. All right. What do I do here? I subtract 36 first, right? And then I have 2x squared equals -36. And then what? Divide both sides by 2. Okay. So then that's x squared equals, what's -36 divided by 2? -18. And then I can square root, right? So x is going to equal square root of negative 18. I see a negative or plus or minus. I see a negative, so I'm just going to take out that negative and put an I there. Okay? Now 18 I can break down. 9 and 2. Now I know that the square root of 9 is 3. Right? Yeah? You can break it down even some more and go 3 times 3, which is 9. Right? But you can also stop there and just know that, hey, the square root of 9 is 3. And that's why we take out pairs. Up here, where I got 6 and 2 and then 2 and 3, right? The reason why I took out a pair of 2's is what's 2 times 2? 4, right? What's the square root of 4? 2. Okay? So whenever you see a pair, that signifies that it's a perfect square. Okay? Like 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on and so forth. That's why we're searching for pairs. Or if you know your perfect squares by your big and beautiful brain, right? You could just take it out right here. Okay? Either way works. Okay? So if I take out that 3, it's going to be plus or minus 3i. If I take out the 3, or I took out the 9, the 2 is left over, so square root of 2 equals x. And that's it. Okay? Cool? Questions? No? We got 2 more examples. Just 2. Okay? If we have this equation, negative 5x squared plus 3 equals 10. Okay, I am going to isolate my x again, right? Same steps, subtract 3, subtract 3. We have negative 5x squared equals 7. Divide by negative 5, divide by negative 5. So we're left with x squared equals negative 7 over 5. Square root, square root. So x is going to equal plus or minus square root of negative 7 over 5, right? I see a negative. I'm going to take it out. And for now, we're not going to be talking about how to simplify this. For now, this is your answer. Okay? I don't want you to simplify it. Only if it's a perfect square, simplify. And I'll show you guys what I mean in a little bit. Okay, my next example. Okay? We're going to learn how to simplify this, but not today. Not in this lesson. All right? Okay, my last example. 5 times 2x squared minus 3 equals 4 times x squared minus 10. Okay, what do I do here? Distribute. So I'm going to distribute out the 5 and distribute out the 4. Okay, so 5 times 2x squared is 10x squared minus 5 times 3 is 15 equals 4x squared. 4 times negative 10 is negative 40. Right? Now what? Subtract 4x squared. Simultaneously, I'm going to add 15. Okay, because I want my x squares on one side, I want the numbers on the other. So 10x squared minus 4x squared, that's 6x squared, equals negative 40 plus 15, that is 25. Okay. And then I'm going to divide by 6, divide by 6. And there are multiple ways of doing this. Okay. All right. I don't want you guys to think like, oh, wait, that's not what I did. I made it equal to 0 first, and then I subtracted 25 on both sides. You still ended up with this, right? It might have taken you 2 or 3 additional steps, which is perfectly fine, right? As long as you ended up here. Okay, so for example, I did this with my other period, right? Yeah, and we added 40 first, and then we subtracted 4x squared next, and then we added or we subtracted 25, and we got here again, right? We took these additional steps, which is perfectly fine if that's how your brain is wired. Yeah, go for it. Doesn't matter, right? As long as we end up with 6x squared equals negative 25, yeah, we're good. Okay, so we ended up here. We divided it by 6. So then x squared equals negative 25 over 6. And then I'm going to square root it again. So x equals plus or minus square root of negative 25 over 6. Right? And that is going to be broken down. I see a negative. So I square root of 25 over 6. Okay. What's the square root of 25? 5, right? So I see a perfect square, right? So x is going to equal plus or minus 5i over square root of 6. Yeah. Because the square root of 25 is 5. Yeah. And then the 6 is on the bottom, right? Is in my denominator here? So it has to be in my denominator. Okay? Yes. Remove the square root of 6. Yes. So what we're going to do here, I'm only previewing the lesson that I'm going to do later on, is multiply this by the square root of 6 over square root of 6. Okay? So in my top, I'm going to have 5i square root of 6 over square root of 6 times square root of 6 is, what's 6 times 6? 36, square root of 36. Well, what's the square root of 36? 6. So plus or minus 5i square root of 6 over 6. That's how we're going to rationalize the denominator, which you guys don't need to today. Yes. They're both perfect squares, then pick the square root of both. Yeah, then take the square root of both. How would you do that? So if the answer came out to be x equals plus or minus square root of 25 over 9 with the I, yeah? What's the square root of 25? 5. What's the square root of 9? 3. Plus or minus with the I. That's it. Yeah. All right. But since the 9 is in my denominator here, it has to be in the denominator here. Okay. All right. And that is your lesson for 11.1. See ya.